Good morning. We have come to question 2 of permutation and combination. Now in this question, you are given a word, Sheridan. I have broken down it for you in this form because it's easier to manipulate and easier to see. Now you are supposed to find the number of code words that can be formed from this word for part 1. If at least 3 of these letters, but not more than 5 letters are being used. Now, we can break this down into 3 parts. If 3 letters are being used, the number of code words that can be formed if 4 letters are used, and the last option will be the number of code words that can be formed if 5 letters are used. Now, each of these category, you can subcategorize them. Now, take for example, the case of 3 letters. You can have 3 E's, 2 E's, or all the letters are different. So let's look at this case first. How many words can you form with 3 E's if you are supposed to take the 3 E's from here? This one is very simple. You only have 1 because the E are identical. How about this? The 2 E's, you have 1 way, and there's a different letters being used here. Now, how many possibilities are there to replace X with SHRDIN? You will have only 6 choices. Now, don't forget we can permutate this letter. Alright, X can be the first, it can be XEE or EXE. So there are altogether 3 letters, so you times 3 factorial. 2 of them are repeated, so you divide by 2 factorial. Now how about this option? They are all different. So how many different letters do you have? You have 1, 2, 3, 4, 5, 6, 7. So 7, C3. Alright. When you use C, you haven't permuted them yet. So you must do times by 3 factorial. Or you can use this is also equals to 7P4. Now you add all this up. That means you add 1 to this, to this. Then you will have the number of code words that it can be formed if 3 of the letters are being used. Now let's look at the other option where 4 letters are to be used. So case 1, 3 E's are being used. So for 3 E's, you have only 1 way. And this one, you can use any of the letters but not E. So there will be 6 different letters to choose from. Now how about this case? The 2 E's, you only have 1 way. Now you're supposed to choose 2 letters out of from SHRDIN. So altogether there are 6. You cannot choose an E because you are supposed only to have 2 E's. So you can choose 6, 2 out of 6. But we haven't permuted the letters yet. So how many permutations are there? So there are 4 letters, so you multiply by 4 factorial. 2 of them are the same. So that answer divide by 2 factorial. Now the other one is you want 4 different letters to be used. So altogether there are 7 different letters. So you can use 7C4. But we can permutate them, so you can multiply by 4 factorial. And this is the same as 7P4. You add all this up, and that will give you the total number of 4 letters code word that you can form with it from it. How about 5 letters? Now, so you can use 3 E's and followed by 2 different alphabets. So 3 E's you only have one way. So there are 6 different alphabets here. So you are supposed to choose 2. So 6C2. Altogether there are 5 letters. So we can permutate them. So you multiply by 5 factorial. And 3 of them are the same. So divide by 3 factorial. How about this option? You have 2 E's. That will be one way. And you're supposed to choose 3 out of the 6 letters other than E. So you have 6C3, and we can permutate them. So times 5 factorial, divide by 2 factorial, because 2 of them, there are 2 E's. Now the last one, we are supposed to choose 5 out from these 7 letters, SHERDIN. So that would be 7C5. But we can permutate these 5 letters, so times 5 factorial. Or some of you may like to use this formula, 7P5. You are asked to find the number of code words that can be formed if all the letters are to be used. Between 2 E's, there must be at least 2 other letters. So what are the possible options? So you can have E separated by 2 other alphabets, E, 2E. Okay? Now, or you can have E separated by 3 other alphabet, then followed by E, and 2 alphabet, then another E. Now, or you can have E, 2E, then followed by 3 alphabets, then followed by E. Or you can have E, 3 alphabet, E, and then another 3 alphabet. Now altogether there are 6 different alphabets. And you can have E, so you can have 4 alphabet, 2 alphabet here, 2 different alphabet here, followed by a E. Or you can have E, 2 alphabets, followed by E, and 4 other alphabets, followed by an E. Now let's work out this option first. Now, this option can be further categorized into a few other categories. Now, what are the possible categories? You can have 2 other alphabet followed by E, 2 other alphabets. You can have it this way. All right. You have 6 other alphabet. Or you can have E, 2E, followed by 2E, and you place the 2 here. Or you can have 1, E, 2. One. Okay. Now, so altogether, how many different permutations are there? Now, over here, you have 6 different alphabet. So for this option, you have 6 factorial. How about this? This is also 6 factorial because all the 2's are represented by, each 2 is represented by 2 different alphabets. Then how about this? This is also the same, 6 factorial. So all in all, this whole thing, right, the number of different code words that you can form with 2 different alphabet between separating the 2 E's. Now altogether you have 3 times 6 factorial. You add all this up, is 3 times 6 factorial. Now how about this option? Now we shall consider this one first. Then for the total of this whole thing, we just need to times 2 because they are symmetrical. Alright, 3, 2 and 2, 3. So we can just times 2. So we will just consider this one. Now, so what do you have? You can have 1 alphabet here, 3 E, 2 E, altogether is 6 of them. Or you can have E, 3 E, you can put the 1 here. Now, or you can have 2 alphabet in front, followed by, no, you can't have 2, sorry, because you have more than, you will have more than 6. So 1, 2, 3, 4, 5, 6. Okay, you cannot have. So I think that's all for this. Now, how many combinations are there for this? This one is 6 factorial. This is also 6 factorial. Okay. Now, this is for this part only. Okay. And how about this? This one, you will have 6 factorial and another 6 factorial. So all in all, you will have 4 times 6 factorial. So the number of code words, if you have three alphabets separating the first 2 E and followed by 2 alphabets separating the other E, will be 6 factorial, 6 factorial, and then 6 factorial plus 6 factorial. And then this option, you have another 6 factorial plus 6 factorial. So in total, you have 4 times 6 factorial. How about this option? Now this one you have no choice, there's only one option. Alright, 3 alphabet in between. So this one you will have 6 factorial. How about this? Over here, you have 6 factorial, and here you have 6 factorial. So all in all, this will be 2 times 6 factorial. So the total number of code words will be, so total code words that you can form with these criteria will be 3 times 6 factorial plus 4 times 6 factorial plus 6 factorial plus 2 times 6 factorial. That will give you a total of 3 plus 4 is 7, 7, 8, 10 times 6 factorial. Okay, you can press the calculator for the answer, for this answer. This is 720, 6 factorial is 720, so times 10, so it's a total of 7,200 code words you can form if you follow this criteria. Now in part 3 of the question, you are asked to find the number of code words that can be formed from this word when all the letters, if all the letters are used and all the 3 E's are together, but must be separated from I by exactly 3 letters. So what does it mean? Now, the 3 E's are together. How do we ensure that the 3 E's are together? So we treat them as one entity. So imagine this is the 3E. Then they are to be separated by exactly 3 letters from I. So this is one option. The other option will be, you start off with the I and you have 3 different letters here and then followed by 3 E's. So how many words can we form from here? Now, to arrange this, there's no other way, there's only one way because the 3 E's are similar. And this one, you only have one way. Now over here, how many remaining letters do you have? You already use up the 3 E and the I. So you still got 1, 2, 3, 4, and 5. And out of the 5, you have to choose 3 to place in between the I and the E's. So you have 5C3 over here. But you can permutate these 3. And they are all different. So times 3 factorial. Or some of you would like to use this as 5B3. This is actually 5B3. But for me, I like to use combination. Then I permutate them. Now, how about the remaining 2 letters? How are we going to place them? Now, one simple trick is, now you consider the 2 remaining letters as this. Now you consider this as one entity. Okay, this is, let's say this is a box. Okay, the box. So now these are the 2 remaining letters, and then this box is the same as this box. All right. So how many ways can you arrange them? These 3 items. They are all different, so you have 3 factorial. Now, not forgetting that you can also arrange them in this order. Start with an I, followed by 3 alphabet, then 3 E's. It's exactly the same. So you find that this is repeated, but in a different orientation. Just now the 3 E's come first, followed by 3 different alphabet, followed by I. Now you have I, 3 alphabets, 3 different alphabets, and then you have 3 E's. So this will be the same thing. Over here you have 5c3 times 3 factorial. And then how many ways can you arrange this item? Again, you have 3 factorial here. So all in all, you add all this. Now in short, you can just use 3 factorial times 5c3 times 3 factorial. And then you have another set over here. So you times 2. That is your, you key this into your calculator, and this is your answer to part 3 of this question. Thank you very much. Thank you for watching. We hope you have learned something through watching this video.